All right, so we're going to expand a binomial with Pascal's triangle. The first thing is to have Pascal's triangle. Um, the values of Pascal's triangle never changes, but in case you don't have it on hand, just know that every row starts with 1, every row ends with 1. So every row starts with 1, then 1 plus 1 is 2, every row ends with 1. Every row starts with 1, 1 plus 2 is 3, 2 plus 1 is 3, every row ends with 1. Every row starts with 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and every row ends with 1. So if you don't have Pascal's triangle on hand, you can always create it. Some notes is to make sure that the first term always starts with the same power given and counts down. Second term starts with the 0 power and counts up, and we'll go over that in the example. So first of all, if I were to give you the binomial 2x minus 4, but I raise it to the fourth power, I first want to use Pascal's triangle to see which coefficients I'm going to use. And a good way just to remember it is just pick the row where the exponent matches the second number. Always the second number because the first number is 1. So if it were to the third power, I would pick this row. If it were to the fourth power, which it is, I'm going to pick this row here. And the reason for that is because the top row is anything to the 0 power, because anything to the 0 power is 1. And then a binomial to the first power would be this row, to the second power is this one, third, fourth, so on and so forth. So a good rule of thumb is just to go to the row where the exponent matches the second number in the row. So with these numbers, I'm going to bring them down but put space between them. So 1, 4, 6, 4, 1. And I'm going to put a plus between them. If they end up being minus, we'll take care of that later. And then I'm going to go to the notes. So the first term always starts with the same power given and counts down. So the first term is 2x. I'm going to start it off with the same power as the one given, which is to the fourth power, and then count down. So 2x to the fourth, 2x to the third, 2x to the second, 2x to the first, and 2x to the 0 power. So you know you're counting it correctly when your first term ends at the 0 power, and it always will when you're using Pascal's. And then for the next note, the second term starts with a 0 power and counts out. So this negative 3, we're going to start it off with a 0 power, and with each term it's going to count up. Negative 3 to the first power, negative 3 to the second power, negative 3 to the third power, and it should end at the same power I started with, which is negative 3 to the fourth power, and that is the power that we're given. So from here, we're just applying PEMDAS. I'm going to just work out each term. Just remember though, that exponents come before multiplication. So I'm going to handle these exponents first. Negative 3 to the 0 power. Well, anything to the 0 power is just 1. Technically, you don't even need it there, but I'll solve it. And here, remember that I put it in parentheses because the first term has the power of 4. That's everything in the first term. So that's the 2 as well as the x. So 2 to the fourth power is 16. X to the fourth power is x to the fourth. And then after exponents comes multiplication. So I'm going to multiply everything in my first term. And I'll get 16, bring down x to the fourth. I'm going to do the same thing with the next term. So negative 3 to the first power is negative 3. 2 to the third power is 8, and then x to the third power is x to the third power. So after exponents, now I take everything in my second term, and then I multiply. So I'm taking 4 times 8 times negative 3, which gives me negative 96, x to the third power. Next term, negative 3 squared would be positive 9. Make sure if you put it in your calculator, the negative 3 is in parentheses, otherwise it'll come out as negative 9, which is incorrect. Negative 2 squared, or I'm sorry, 2 squared is 4, and then x squared, bring that down. 6 times 4 times 9 are the 3 I'm multiplying, which gives me positive 216 x squared. Negative 3 to the third power is negative 27. 2 to the first power is 2, and then x to the first power is x. And then after exponents, I multiply 4 times 2 times negative 27, which gives me negative 216x. And then for the last term, again, anything to the 0 power is just 1, so I'm not even going to calculate that one. And then negative 3 to the fourth power would give me positive 81. So I have 1 times 81, which is positive 81. And if you look, this is the binomial expanded. And then one little trick too is if you ever have a subtraction sign in your binomial, just look at your expansion. It will have alternating signs. For instance, the 16 is positive, the 96 is negative, the 216 is positive, the next term is negative, and then the final term is positive. So there will be an alternating change of signs, and I hope this helps.